Hello and welcome to another short video to help you understand the work you're doing in science this year. Now, we've been looking at all sorts of things and we've only just started looking at graphing using speed and time, which is slightly different but almost the same to what it was for distance and time. So if we look at what the basic graph looks like, we see that we have speed going up the vertical or up and down axis, and notice we put the units for speed are meters per second. Remember the slash means per. Down the bottom we still have time, and it's still in seconds. So let's see how they're different. Right, this is the one we had that's very similar to the distance time one, but let's think about it. What's happening here is the speed is slowly increasing over time. So because the speed is slowly increasing, it's speeding up or it's accelerating. And as before, we said the straight line means that it's at a constant rate. So that means that it's not quickening up and slowing down, it's just quickening up at a steady speed. Right, so this looks what it would look like in terms of trying to work out which has got the highest acceleration or the largest acceleration. Similar to the distance time graph, we see that if the one is nice and flat, it's not very steep at all, it's got low acceleration. So it's slowly starting to gather up its speed and starting to get faster and faster. Then we got one with a bit more of a slope on it, a bit steeper, so it would be going and accelerating a bit faster than that. So its speed would be changing faster and it would be gradually getting faster and faster. Now then we can go to a steeper one still, and this would be the quickest one. And it would cover the biggest distance, of course, and it would be going the fastest at the end of it. Right? It would be going this quickly at the end of it. These ones are only going this quickly, so we can use it to read off the values if we have them. Right, remember with this one, if we had a horizontal or flat graph in distance time, it told us we weren't moving. But in this one, we are saying that it is not changing its speed. So its speed is remaining the same. So therefore it's not speeding up, it's not slowing down, so it's not accelerating. So when you see a flat one now, you know it's not accelerating. And lucky last, we've got this one. We can see that we start off at a high speed and we change to a low speed. So we're slowing down. But slowing down is also what we would call accelerating, because accelerating simply means that we are changing the speed. More to come.